welcome Brad to the stage.
Thanks. No, that's fine. Thank you. Nothing like typing your password in front of everyone. Okay. A little bit about me. My name is Brad Giesemann. And just to get the talk started here, of a little bit about me and where I came from and how I approach these topics. I started in security, was a security engineer at a managed service provider, went to pen testing and security consulting. But in the past 8 or so years, I fell in love with public cloud, DevOps, I'm sorry, that's an overused term, and kind of in conjunction with that ethical hacking education. And running CTFs and competition workloads in VMware and then later moving those into AWS on Kubernetes. Little side note, it's not really recommended. It seemed like a good idea at the time. But in the past couple years, specifically focusing on container security and Kubernetes and doing a little bit of independent consulting around that. And if you're curious about that specific topic, I did a talk, Hacking and Hardening Kubernetes Clusters by Example, at last year's KubeCon. So dissecting this title, it could be nebulous for some, so I'll try to explain it. Really, it's about getting visibility of all the relevant account activity to determine if it's desired uses of your resources. And when I was doing this talk or prepping for this talk, I kept going back and forth between multiple roles. I kept thinking of it from this angle or that angle. You know, how would I approach it if I was this person or that person? So hopefully I can cover a little bit from each of these perspectives throughout this talk. So hopefully get something out of it from any of the roles that you might have or be in. So to give a little bit of an agenda, a little bit of a roadmap, I'm going to cover some of the challenges, try to cover the problem space a little bit, talk through the shared responsibility model and how I think it might need to be tweaked a little, the cloud-specific attack lifecycle, how that differs from a traditional attack lifecycle, talk about how the data sources come into play when it comes into detection, go through a quick example attack scenario, and then get to the meat of the talk, which is probably why you're here, to see a little bit of each of the major cloud providers' offerings when it comes to the native services. And we'll talk about how the partners integrate later. And then I do want to spend a lot of time at the end talking about key takeaways, because I think there's things to learn from these strategies that go beyond just the detection capabilities that they offer. So what makes detecting malicious behavior different in a cloud environment versus a traditional environment? Well, there's some fundamental assumptions that change, right? So the inventory is typically very highly dynamic. In some cases, systems come and go in minutes or hours. When we're talking about functions, we're talking about milliseconds in some cases. So that changes everything in terms of how you do inventory, how do you understand what's in your environment to be able to detect it. You need the visibility. And there's a heavy focus on automation with cloud as infrastructure as code and cloud services. There's a chance to amplify good behavior, but there's also really good opportunities to amplify human error. So if I'm managing 1,000 systems with one line of code and I make a mistake, it applies to all 1,000 evenly. And I'll talk a little bit about this later, but the shared responsibility with the provider, I want to hone in a little bit on some of the detection gaps that are potentially there. And when everything is an API, the traditional approaches don't fit. Installing agents on systems, talking to dedicated masters on static IPs, and that methodology just doesn't work in a cloud-native environment because things are expected to change. Things are expected to go away, come back, auto-scale up, auto-scale down. Oops. And I should note the pace of innovation, part of the setup of this talk is understanding why we're in this position, why there's so many challenges. The pace of innovation really does leave a pretty big wake. When there's increased business competition in the cloud-specific environment, everything's focused on shipping features first. You hear terms like fail fast, fix fast, you know, outsource everything that's not your core competency and things, and often that includes security. And when you combine that with the explosion of cloud services, the perimeter just dissolves. You know, there's source code over at this hosting provider, there's CI/CD over at this other provider, and you have integration directly with your cloud accounts. You know, it's not just what you see in your console that you have to worry about. And I've been a part of this. I like to think I've been a part of this, the renaissance of the infrastructure and deployment tooling in that space. Anybody with a credit card can go sign up for a public cloud account and in 20 minutes with a little bit of code have a gigantic, monstrous infrastructure that now is new and exciting attack surfaces waiting to be looked at. And I think it's common across every industry really in IT, but the intersection of the number of people that understand infrastructure and DevOps and cloud native and security, there's an even bigger gap. And with every service that comes out, that's a whole new world or a whole new industry that just got added as a service to the cloud provider. It's incredibly hard to keep up. So I talked about the responsibility boundary. I want to break that down a little bit. I'm borrowing this from AWS. The shared responsibility model. What the customer is responsible for when it comes to security and what the provider is responsible for security. Now, yes, this is AWS's model, but it does apply to the other two that I'm going to talk about. And they always phrase it with security in the cloud, that's your responsibility, and security of the cloud, which is their responsibility. But I argue there's a missing layer. And they had a clean black line there. I argue that this layer is very important for your understanding of where the threats and things really, where the rubber meets the road, so to speak. There's actually a shared responsibility at this API layer, and that's the service API endpoints. The services, the APIs you interact with when you're trying to move or install or configure infrastructure. So, from your perspective, you're worried about your data, your applications, your operating systems, and encryption at rest and transit. But when you go to, say, spin up a new instance, you just hit an API. You give it valid credentials and you get a new instance. Flip that. If you're the cloud provider, I don't mean to be mean here when I say this, but you're just a paid API client. To them, it's just credentials and a request to an API. Does that match? Okay, spin up the instance, do the thing for that person. So what happens there is there's an opportunity for detection gaps when it comes to I'm in charge of responsibility of handling the keys that work to those APIs, and they're responsible for managing those APIs, protecting it for all their customers, but they're trusting you to manage those keys. Raise your hand if you know about, you don't have to say that if you did, but if you know about someone who's had their credentials compromised in a cloud environment. Okay, a fair number of hands, right? It happens easier than you think, and we'll talk a little bit about more how that can happen. So protecting them is very important, and it's very nuanced. So I talked about the attack lifecycle, what makes it different. I apologize, this is oversimplified on purpose. This is not don't take this as the right way to do it. I'm simplifying for a reason. The traditional attack path is visualization of how people attack infrastructure. Reconnaissance, scanning ports, identifying systems. You get that initial compromise, maybe you establish some persistence, some callbacks, some command and control, and then you spend most of your time privilege escalating and moving laterally in the environment, typically with valid credentials so that you blend in. And then maybe your goal is to exfiltrate data or install malware that does things and exfiltrates sensitive data, right? I broke this apart a little bit just to kind of visualize some of the things I'm going to talk about a little bit later in the talk, but at that initial compromise stage, the second level, the leaked or stolen credentials is something I don't think people really associate with the cloud attack lifecycle, in that often keys are just everywhere. So you don't need to break into a system. You don't necessarily need to be a red team or a pen tester, and you can have very high level privileged credentials in an environment, and you're already very far into the attack lifecycle. The second thing I want to call attention to is the lateral movement, privilege escalation, and credential collection and enumeration layer. That's very muddy. In a cloud environment, it's very fluid. Keys are associated with applications, with instances, inside functions. They're just API calls away. So if you're in an environment and you're breaking into an environment, your lateral movement, there's no single downward path in this diagram. You're going to be moving around a lot in that layer to get where you need to go. And then on the final layer, I'm going to call attention to the misuse of resources and the disruption, as well as the covering of the tracks. The data exfiltration, that's great. You get sensitive data, you send it back, and alert legal that PII was leaked. But the misuse of resources, crypto jacking, crypto mining, using your cloud account to make money for them. But then also there's a few, I don't think it's as public as it could be, but I think there's a few very well-known cases of companies that are literally light switched off. Credentials were gotten that had enough privileges to basically delete everything, shut everything down, and kneecap the business. And so they go under. And because those APIs are the same ones that you or I would use to manage that system, if you have those credentials, you have that access to be able to go ahead and turn off those services. You have the same ability to cover your tracks. So disabling logging, disabling audit logging, alerting, notification mechanisms. If you're root in the account, you can disable and make the client or the customer blind. So I'd love to go into all of this. I really enjoy this problem space, but I have to defer to some really good resources in terms of if you want to learn more about escalation, enumeration, persistence, and covering tracks in specific cloud environments. These are AWS specific, but I guarantee the concepts work in all the three that I'm going to talk about. It's a whole world, and it's a lot of fun stuff. So what detection methods are available? Well, when we talk about detection methods, we're talking about data sources, where we're getting the data for that visibility. We have the standard network level DNS queries and network device-based things, although I don't know if you know that not many people run network devices inline inside of cloud environments. They often just have outbound access and things just wide open. But still, I want to call attention to the host-based detection capabilities. That's still very important. That's often the first point of indication. So you can't run your cloud instances and say, oh, I'm not going to have host-based protection or AV or things like that. You're going to want to still run that. That's a really good place to get contextual data because you'll know where it's coming from. You know where it hit right away. You don't have to infer it from the other angles of things. And I think what's different for the cloud world is from a detection standpoint, there's a whole world of nuance and detection capability of how the APIs are used. That's why I was focusing on that earlier. Things like simultaneously accessing the API from this country and this country within 5 minutes, that's suspicious, right? Using terminated keys or keys that were recently rotated, that's a good indicator that that person wasn't getting those keys automatically refreshed from their application. That's something, especially when somebody's terminated and recently terminated from a company, they still have access. Uncommon service API usage, meaning I use compute, but I don't use this database service. All of a sudden, database is spun up, or all of a sudden, all these GPU-backed instances are spun up. That's suspicious, right? Because that might be crypto mining. People tend to not spin up 1,000 of them at once, right? So one of the things that I think if you're looking at this space, that's a lot to talk about. One of the things that you want to hone in on if you're going to look at like the top 10% or the 80-20 is specifically detecting when permissions are changed on user accounts, and especially privileged user accounts, so administrator access. So anytime something that has a lot of privileges assigned to a user, anytime a password's changed or credentials rotated, those are very key things to hone in on. And then yesterday there was a talk by Will Bankston compromising AWS account credentials, or detecting that, around the internal IAM credentials that were attached to instances and using those outside the organization. So at Netflix, you can imagine the scale of that. That's a really huge challenge, and I thought he did a very nice job covering that topic, so you can dig into that. I would like to talk about dozens of attack examples, but I picked one because it's hopefully easy to understand. Shout out to anybody who runs Kubernetes. Anybody? Couple hands. Oh, good. Excellent. You don't need to know Kubernetes to understand this example. Just wanted to see who's out there. A car manufacturer was running a Kubernetes cluster on AWS. They accidentally exposed the admin dashboard to Kubernetes. And by default, that doesn't have any authentication or authorization. And it has a lot of privilege in that environment. And what the attackers did, first they masked their source from a CDN. So that's preventing the detection of who they really are. But they installed crypto mining workers using the cluster mechanisms. Hey, Kubernetes, go spin me up a whole bunch of cluster workers. But they purposely throttled the CPU to keep it under detection. And because of how Kubernetes interacts with the cloud services, there's actually some tight integration so that it can store things in storage buckets or auto-scale number of nodes to expand for workloads. They had an opportunity for exfiltrating data right out of S3. So they use the admin dashboard, they go get the keys, and they go ask S3, show me all the buckets, download all the data. Probably it was a 20-minute exercise in that case. Now I'm picking on them, but they're not alone. There's been other companies that had this exact same issue. So how would you detect this attack? Well, this isn't a comprehensive list by any stretch. There's some more of that later, but in the case of this, using those instance IAM credentials, which Kubernetes leverages, when you use those outside the environment, that's a huge indicator that something bad is going on. And specifically DNS logs of anything that was related to crypto mining lookups or downloading malware and the NetFlow logs associated with those. And then finally, the application logs of the dashboard. My guess is that they weren't looking at those logs. Hey, why are there repeated login attempts from this admin dashboard from a public IP? My guess is that they weren't looking at that. So my understanding serves that it was somewhere between 4 and 6 weeks before they detected it. Now, I mentioned that you don't necessarily have to break in order to have access. So I want you to be aware of some other things that I can't go into too much depth here, but I wanted you to be aware of these in terms of where credentials can come from. So theft of credentials. Every developer or sysadmin or user of cloud services typically has keys on their laptops or workstations on their jump hosts, and they're susceptible to the same attacks that everyone else is in terms of phishing, malware, and backdoored libraries and tools, because devs download NPM and packages, and that comes all in there. There's opportunities for those packages, if they're backdoored, to go reach over and grab credentials and send those back home. From a malicious outsider perspective, remember that there are a lot of third-party services that integrate with your account, right? So source control hosting is a great example. Continuous integration, continuous delivery, things that build your application, deploy it to your systems. They often have credentials that go into your environment. And so if they're compromised, quite likely you're then very, very quickly compromised. And when employees are terminated, failure to rotate those keys. I'm guilty of that. Not that anything happened, but you remember, oh, that was a week old, that person left, I forgot to rotate those keys. So that's somebody leaves, they still have access to the system at a privileged level. And then from credential leaks perspective, you'd be surprised, maybe you're not, of where these keys can show up. Just people give them away by accident all the time. When I was prepping for the prior talk that I discussed, I found credentials to a Docker registry for a company that builds services for people running in Kubernetes clusters. And that had access, I told them right away, and they told me later that it had access to all their images that get deployed in their customer clusters. So had I just checked out those images, modified them slightly, and checked them back in, they may have been automatically deployed to their customer environments. So, the meat of the talk. This is going to be, because of the time, this is a little bit higher level than I'd like to go. I'd love to go into each one of these. It'd be another talk for each one. But the native cloud security services that each of the big three provide. So specifically, Azure Security Center, GuardDuty and its supporting services, and Google Cloud Security Command Center. Just a frame of reference to set expectations. The lifespan or the earliness, these are so early that it's hard to say, have a lot of expectations of their maturity level. So just when you're looking at these, don't expect something that's been in service for 10 years. In some cases, less than 2, in some cases, not even fully released. They're still in alpha. So just kind of have that perspective when you look at these. And I tried to find common questions that I could ask across all three and show the comparison and contrast of all of them. It was very difficult, I'll be honest. But the things I want to cover are what data sources do they operate on, what visibility does that provide, what things do they not cover, and that's kind of a challenge, I'll explain why. How easy is it to onboard, how much does it cost, how well does it integrate with other security services, and how accessible are they to customization. And finally, what I wanted some of the talk to be about a little bit is validating the detection capabilities, but you'd be surprised at how difficult that is to do. So when you're looking at these, if you identify with one of these roles, these are probably some questions you're going to ask or want to take away with. So hopefully I help answer these as we go through. From an attacker and a defender's perspective, that's pretty straightforward. But if you're a business leader or if you're managing a team, you're going to be thinking of what my exposure is, what's my ROI for efforts of building versus buying versus integrating. And if you're a builder, what things do I no longer have to build anymore? That's huge. So first up, Azure Security Center. It's generally available. It's barely 2 years old, and if memory serves, it's summer of 2017 where the advanced threat detection capability came on. So they're iterating over time. But their general approach is trying to be a unified security management interface, something that works across your on-prem and your cloud workloads with a very similar approach. And the cost is $15 per system per month. So that might be a lot or a little, depending on how big your environment is. If you have thousands of VMs, that can add up. So I'm going to touch on these key features really quickly. There's so much more to go into, but I think these are the things that you want to know if you're looking at them. You know, what things would they offer that would catch my eye? That unified hybrid security dashboard, that's something if you're comfortable with the Windows way of managing systems on-prem, a lot of it will carry over, and that might be good for you or that might turn you off depending on where you come from. It has a nice recommendation engine, so they do a lot of security hygiene things that you can tap into and customize, so I think that's a really powerful feature. And Microsoft, of the three, is the only one that offers what I would consider a native host-based detection agent. So operating system logs, application logs, missing patches, weak configurations, those things, those are baked in part of that $15 a month. So if you opt to install those agents, you get all of that right back in that dashboard. Another thing that Azure does well is they integrate their workflows with the partner ecosystem. So in some cases, it's really just put a license key and check a box, and you can have a security capability deployed in your environment. I think that's very powerful, and I'll touch on why that is in a little bit. And some of the things I noted, the custom alert rules, that's a really nice interface that they have. You can get it almost any piece of data and make custom alert rules with a very simple query language. And I think that's really powerful. Coming soon is file integrity monitoring, and the REST API. I think it's one of the more fully featured REST APIs because it's been in service the longest. I wish there were better diagrams. I'm not very good at doing diagrams. I try to keep this simple. But basically, when you're looking at detection, where does the data come from in Azure Security Center? It's things from the API, it's things from the network, it's things from the agents that are installed on the system, shipping the logs back and things, but it's also taking those from the partner solutions and putting them in. And I just highlighted a couple of the operating systems so you get an understanding of, it's not just Microsoft. They have a lot of Linux support as well. So if you boil it down, this is one of their diagrams. I'm using it straight up. Monitoring the traffic, collecting the logs, and analyzing it for threats and putting it into a dashboard. I mean, that sounds simple, but it's not, as you can all probably imagine, but that's what they're aiming to do. So the key things when they do detection, they're talking about threat intelligence, they're talking about IP addresses and domains. When they're doing behavioral analytics, they're talking about what the host can see if you have the agent installed. I think things to point out are the monitoring of process executions, crash dump analysis, which I think is, when I learned about that, I was like, oh, that makes sense. When a failed exploit happens, it causes a core dump, they can actually auto-analyze that and see what was happening and create detections out of that. And of course, with Azure Active Directory, there's a lot of integration with the authentication services, so the login activities and account enumeration that would be in that lateral stage. Are ripe for detection. And of course, things like PowerShell activity and then ingoing and outgoing network attacks. So a quick look at the dashboard. It's a very simple interface. This is my dashboard. I'm going to zoom in on an example from theirs because it has more data. I don't have thousands of VMs to spin up just for this. But at the top, there's a policy and compliance layer. So they're saying, you know, of all my systems, on-prem and in the cloud, are they following a meeting policy, things that you can configure? And from the security hygiene perspective, you know, are the agents installed? Are they up to date? Are there missing patches and those kinds of things? So that's the top two layers. And on the bottom layer, the threat detection. So how many attacks over time am I seeing and what severity are they? And one of the things I wanted to point out, because I think it was really cool, it was kind of a nice surprise. You know, you install the agent and you don't really know what's going to happen. And all of a sudden, within a few minutes, I get, oh, I'm missing all these patches on both my Windows and Linux systems. I was like, oh, that's very nice. Thank you for showing me. I'll go hit update. And when I mentioned the custom alert rules, this is where you can generate those in the log analytics section. So you can put filters in and make very custom, very granular queries that go, you know, down to the process level or down to the event ID level and things, and make those detect and send notifications wherever you want them to go. So, kind of wrap up, talk about the value add. I think their strength is the hybrid first approach. So carrying over all that understanding of managing Windows systems and Windows environments into Azure to make that as seamless as it can be. Adding that agent, that's part of their detection capability. Doing a very good job of their partner marketplace. I think there's a lot of room for more vendors to come into that partner marketplace, but there's a few in there that are really easy to integrate. And of course, the strength of that REST API and that analytics service that you can trigger notifications on. Areas for improvement. So some of these are going to be repeated for all three, and I'll get to those at the very end. But the detailed list of anomalous detection capabilities is not yet available. It's still kind of behind the doors. And the ability to tune those detections is not available to you. So you're trusting that Azure's security teams are alerting you on things that you want to know, but you don't really get a chance to see what those are. And one thing I noticed that there is a potential delay from the agent being deployed coming back into the dashboard. So if your workloads are really bursty and they go and come and go in 20, 30 minutes, it might not actually register events coming back in that time. And something that AWS does that I didn't see a way to do here was adding custom thread IP feeds. So if you have known block list or known good lists to help their detection capabilities. Okay, switching gears to to Amazon GuardDuty. Now, when I say GuardDuty, I'm really talking about a couple services that GuardDuty uses as well. So it's not just saying GuardDuty, it's also CloudTrail, CloudWatch, and VPC Flow Logs. And GuardDuty was announced in December, so it's relatively recent. And it's taking, I'll explain where it gets its detection from, but it's taking those events and making threat findings off of those things from that narrow space of what it's looking for. What's good about it, it has a 30-day free trial, so if you want to see how much that's going to cost based on your workloads, based on the network traffic, you can try that out without having to pay a dime for that first month. So where do they get data from? They get data from CloudTrail events, VPC flow logs, and DNS logs, right? Notice no host-based items in there just yet. That's for you to bring, right? So what things can they detect from that perspective? The known good IPs and domains, environment-specific baselining, which we'll talk a little bit about, and the IP list that you supply. And what they do is they generate those findings, they put those as CloudWatch events, which you then can build on Lambda functions and things to do your advanced alerting and advanced notification and other parts of the workflow. If you use AWS in any large scale, you'll find that there's something called account sprawl, AWS accounts all over the place. What's really nice is that GuardDuty can be centralized. So you can have a centralized AWS account that takes GuardDuty findings from all of the member accounts. So you don't necessarily have to be involved in that dev team or that operations team's environment, but to have those events sent to you. So a little bit of how CloudTrail works. CloudTrail is basically all the account activity that happens. If you want to think of it crudely, it's all the API activity of who did what. That goes into a CloudTrail, which is basically a way to get that into an S3 storage bucket, and you can trigger CloudWatch events off of that and do fun things. And so that's what GuardDuty takes advantage of. When it looks at CloudTrail events and the VPC flow logs and DNS logs, it pulls those all together, performs analytics and measuring against baselines, and it creates findings. So I'm not going to go through all the findings here, but it's important to understand that from those capabilities, those detection sources, there's certain things that they can detect. And one of the things I think AWS does a really good job of is detecting the behavior patterns of the API usage. So I'm going to show a demo here in a second of what that looks like. But first, let's dive into the dashboard. It's a standard AWS console. It's very clean, very simple. But if you dig in a little bit, you can see I was doing some malicious activity on purpose to try to trigger some things. And in this case, I was exfiltrating data via DNS queries. Overly long DNS queries that encapsulated data on their way out. And so you get a nice finding. It says, hey, in human readable terms, this instance was attempting to query domains that were overly long. It looked like it was exfiltrating data. This is the system that it was on when it was last running, if it's running, and things. And then at the very bottom, it says, here's one of the example DNS domain lookups. It's actually cut off because there's so many characters of data that's encoded in that host name, but it's that long string at something.com. Okay, so it's time for a demo. Rhino Security Labs, I think it was July 30th, so this is very recent. I added this kind of late to the game here. They released something called CloudGoat. If you're familiar with WebGoat, a vulnerable web application that purposely is for educational purposes, Rhino Security Labs released CloudGoat, and I slightly modified it for demo purposes for time reasons, but it's a safe practice environment where they purposely orchestrate a few things in AWS, and you can see and move around how things work. If anybody from Rhino's here, thank you very much. That's an awesome contribution in the community. So from an attack path perspective, this is what the demo is going to cover. We're going to have a server-side request forgery vulnerability on a web app. We're going to attempt to enumerate the API access unsuccessfully. We're going to escalate ourselves to admin. We're going to then enumerate successfully, exfiltrate some data from an S3 bucket, make a persistent user account that has administrator access, and then try to cover our tracks. And then we'll see what that looks like when it goes inside the environment. So you can see my server-side request for you. This is a very sophisticated web application. It takes a URL and it fetches it for you on behalf of that instance. There was an attack that I was going to show that used this in the real world, but it was much more subtle and really hard to understand. But basically, you're getting the web server to fetch the URL contents on your behalf. And because I can't type as fast as I'd like to, and time constraints, I'm going to do this pre-recorded video here. But basically, we're showing that we can get the user data, the instance bootstrap data, and now we can start querying the metadata API to get instance information like what IAM roles it has attached to it. And so here I'm kind of walking through that traversal of that path to say what's the name of that URL, so I can see what credentials are attached to this instance. And I'm hoping that these credentials give me some level of access to the API that I don't have just publicly. So we notice that the role name is EC2_role, and that's something that you need. And when you hit this URL right here, you're getting IAM access key, instance access keys. Let me pause that for a second. These are rotated between 1 and 6 hours, and they're attached to the instance. They're meant to be used by applications that are on that instance. And so when that application wants to go interact with the AWS service, it goes and asks for these via this URL, and then it uses them. And then every couple hours, it rotates them. So it's very important as an attacker to use these quickly and establish persistence. So that's what I'm going to do. So what I did is I copied those out. I'm going to put those into some environment variables just to kind of set up the demo. All right, so now they're in my environment. So whenever I run AWS commands, they're going to use those keys. I'm just showing you that they're in the environment there. So the first thing I'm going to do is say, who am I? This is a suspicious call all by itself because almost no client library does this, but I'm an EC2 instance role. I'm going to try to list the users in the account, like, hey, show me all the users in AWS. I'm getting denied. I'm going to describe all the instances, show me the instances running, again, a deny. List me all the S3 buckets, again, deny. It's getting frustrating, right? Is CloudTrail enabled? That's something that'd be nice to know if I'm an attacker. I want to see if somebody's watching what I'm doing. And is guard duty enabled? Again, no. So what I'm going to do here, it's a little bit of a sleight of hand for the sake of the demo, but let's assume that that instance set of credentials had the ability to add access or privilege escalate. And there's numbers of ways to do that. But in this case, I'm able to attach a policy to my role. In this case, I'm attaching the administrator policy to my role. Okay. And so now I have to wait 20 seconds or so because it takes a little bit of time on the back end for that to reconcile. But now, those instance keys have admin access. So if I go back through those same steps, I'm now admin. I sudoed in parlance for Linux, right? So when I'm walking through these calls, I'm saying get the instances. Now I can see that answer. Listing all the S3 buckets. Okay, ooh, my PII bucket at the very bottom. That looks interesting. Let's see what's in that. 49 bytes of PII. I've hit the jackpot. Alert legal. This is going to be a bad day. So I'm going to copy that down. Very simple. Okay, what's in PII.text? I promise you that's fake information. I just made up numbers. So don't write those down. Apologize if that is any kind of collision. So, persistence. Those keys rotate, so I want to be a persistent user, right? So I'm going to go ahead and create a user. I'm going to name it backup admin, so if anybody were to look in the UI, it just wouldn't look out of place. It's not going to be my bad attacker. I'm going to create some access keys that don't rotate. And I'm going to attach, in a similar way, I'm going to attach admin access to that user. Lastly, covering tracks. So I did a whole bunch of bad things and it's getting logged. I don't want that to be in the logs anymore. because I'm admin, I'm going to go turn off the light switches, right? So describe the cloud trails, and then delete them. And I'm going to describe the guard duty detector and try to delete it. And there was just this beautiful serendipitous issue when I was recording this, and I thought, should I redo this? No, I'll leave it in. What happened was those instance credentials rotated as I was doing the demo. So I had admin access, but the keys I was using literally expired as I was running through. So it's just something to be aware of. If you're an attacker, you need to establish persistence right away. So they're not going to, if somebody gets access, they're not going to sit there and wait to privilege escalate. They're going to do it right away. So you're going to see a lot of activity in that short first few hours or so. Because they might lose that access. The vulnerability might get patched and they lose their way in. So looking at that instance role, this is the original. When I hit refresh, you're going to see the administrator access was added to it. So this was the modification I did to the policy to make this possible. It's a little bit of the sleight of hand. And this is the admin access. So you can see the result of that API call. I said, hey, give myself admin access. That's what it looks like in the environment. I have access to everything. So now, what does that look like in guard duty? Well, first, I'm going to pause it right here. There is a delay, right? So things come into CloudTrail, there's a few minutes of a delay. There's things that come into guard duty based on CloudTrail, there's a few minutes delay there. So this is actually from a prior run of the demo. It shows up later, but it's not near time, right? It's 20 to 30 minutes in a lot of use cases. Should just be cognizant of that. But in this case, it's a very high confidence finding that what I did was pretty bad. If somebody did this, you would want to be taking immediate action. So I'm going to drill into that, kind of blow it up. Hopefully that's not too bad. So credentials created for an instance account were taken out of context and used remotely from this bad IP. These are the key names. This was the assumed role, so that's a suspicious thing in some cases. And there was a describe instances call that was done. And where did it come from? Oh, that's the source IP. And so I'm going to stop the demo right there for time purposes. Where's my presentation? There it is. Great. When you, I'll skip that, sorry. So the value add, zero impact setup. Guard duty is almost a one click. So it's almost, you really should do it. And it's so seamless, it doesn't change any of your workflows, it's all done kind of on the back end. And one of the things I liked about guard duty is that they do a lot of detections and they tell you what those detections are. Are they all encompassing? No, but what they are detecting, they're the most transparent about what things they're looking for. And of course, because AWS is the largest, they have a broad ecosystem of partners. And I think they do the best job or a more clear job of misuse of API keys. I think that's something that AWS gets a bad rap for. That's where you see a lot of things in the news. But they do a lot of things to help detect that with guard duty. Similar findings in terms of areas of improvement, tuning and custom detections. This is really, you're just enabling the service and getting what you get out of it. You're giving it a little bit of intelligence with the IP lists, but you don't get to dig your hands in and modify them too much. And from a unified security dashboard perspective, it's just the way AWS does their services. They're all kind of separate things. I would really like to see that condensed dashboard. I really liked how Azure Security Center does that. Moving on to the third. So Google Cloud Security Command Center. It's almost not fair to include CSCC because it's still in alpha. I don't know that very many customers are on it yet. And so just look at it from the perspective of here's what's to come, and things will change. And it's almost a guarantee that they will change. So what I say right now might already be expired because they iterate so quickly. And it, sort of like Azure Security Center, is meant to be the central place to funnel your security findings from all of the things in your environment. Things you generate, things that your partners generate, and things that that GCP generates. So they have a heavy focus on the discovery and inventory aspect. So it's constantly scanning your environment to get an idea of what's in your environment, so it then knows to be able to correlate findings back to instances and engine, app engine instances and things. Now, they talk about anomaly detection of finding botnets and cryptocurrency and suspicious network traffic, but there's not a lot of information on this. And right now the cost is unknown because it's in the alpha period. I don't know what it's going to be based on. My presumption is it's going to be based on amount of traffic that they have to parse for you. But what they do well is that centralized finding dashboard, kind of like Azure Security Center. It's a single place where all the findings go. So things like Cloud Security Scanner, the DLP bucket scanner, Forseti for configuration and policy, and all of the third-party security solutions that you'll see in this dashboard here, they all go to that same place, and I think that's really important, and I'll touch on that in a little bit. And from that central place, they then have a lot of options for real-time notifications and a very full-featured REST API. Again, lacking the architecture diagrams because it's not even yet public. It's a very similar process, taking from all these sources, putting it through that API, getting that visibility to that dashboard, and then moving it on to alerting and notification. It's really hard to say what they detect because this is what they say on the website. There's no public information, it wasn't offered. That's not a knock, it's just it's not public yet. So when it becomes available, keep an eye on that space to see what they're actually looking for. So I want to dive into the dashboard really quickly. I'm going to zoom in a little bit on that upper left-hand side. Again, that focus on that inventory. On the right-hand side, focusing on the findings, you can see a couple of the partner integrations that are already in this demo account here, and you can drill into these panels and see what's going on. You remember that PII text that I put in that S3 bucket? Well, I put it in a storage bucket in GCP, and I ran the DLP API just to generate some findings, just to see what it looked like. And you can see that it triggered on it, hey, it found an email address, a phone number, and a social security number. And it's coming through the same place that you would find any of the other findings in your environment. So quick look at the dashboard. Digging in, it's very early stages of the UI. I think it's gonna change as we go here, but it shows you all the relevant data that you need. It's very clean and very straightforward. Again, the value added here, zero impact setup. So you don't have to do anything, you just enable that capability and it starts detecting, starts being available for those log sources. Very strong partner focus. In other words, in that main findings dashboard, your partners that are integrated are right there. You don't have to go to a separate UI or do anything like that. And if you're familiar with Stackdriver for how Google Cloud pulls in logs and metrics, it's a similar framework style for security events. So that's kind of the same parallel. So it's very framework oriented. Again, just because it's not released yet, it's still in alpha, and they don't have a really comprehensive detection list or capability set. So by that as well, the same things for all three, tunability, customization, and native notification and alerting. There's actually a separate component that you need to integrate to be able to do the native alerting. Okay, so stepping back a little bit and trying to take what I've learned and try to give it to you in a way that you can take home and make sense of. Common areas for improvement. The visibility is dependent on your implementation. If you have host agents installed or not, that makes a big difference of what these services can offer. The detection capabilities are hard to understand. I really wanted to go through this talk and just, detection per detection, trigger it and see what can work and what doesn't. Honestly, that's hitting a black box, and that's interfacing with ML and AI and baselining. It would take years to actually infer that from testing. So by that same token, it's really hard. If you're defending your organization, you don't know exactly what they're detecting. How do you know what gaps you have? If they say they're detecting botnets, you might say, okay, well, how do you do that? You might not have that visibility. Or maybe you like how they are detecting botnets, but you want to add just that one little bit just to make it work for your environment. You might not have that access. Hopefully that improves. And from an integration perspective, some are point and click and drop in a license key, and others are hitting APIs and integrating like you would expect. I expect a lot of movement in this area and improvement in this area. And just a personal note from an education perspective, I thrive on documentation. I thrive on walkthroughs and demos. And I would love to see more from the cloud providers giving us the best practices of how to secure their environment, because they're the ones who know how to best see that. They see all the customers, they see all the attacks. They should be giving out the best practices for how to implement these and how to tune these. And I think that area will mature over time, but it'll take some time to get there. So, you might be asking yourself, if I enable this checkbox, am I secure? If I'm using the provider native threat detection services, is that all that I need? And the answer is probably not. Now, should I adopt? And I argue yes. The cost in a lot of cases is so low, you're going to want to go ahead and enable that, because whatever detection capabilities that they're always continuously improving upon, you'll get that benefit. So for instance, if you have an AWS account and CloudTrail is not enabled and GuardDuty is not enabled in every single region, go home and do that right now. Maybe you don't even look at it. But if you do, you might get an alert someday that you're happy that you went and enabled those checkboxes. And stepping back, I think when I kind of looked at all three and then I saw the commonalities, I see kind of a shift in how security events are collected, analyzed, and processed and forwarded and worked into work streams. I think the most important thing to watch here, and again, very early stages, is that this is actually them providing a framework. The heavy lifting of installing agents and collecting, doing that all yourself, that's a lot of wasted effort, right? That's what AWS calls undifferentiated heavy lifting. I think it's a perfect term. If the cloud provider can standardize on the way that it collects and analyzes logs that you can tap into, that's work you don't have to do yourself. That's money you save. So if you even have a mature pipeline right now today, look at how they're doing it. Maybe there's some work that you can take off yourself, or there's systems that you can deprecate in favor of their APIs. Because that's money you're spending, time you're spending maintaining that you don't have to. And what I see coming into play is in the very near future with these partner integrations, they're coming in, they're using those same APIs. The cloud provider's providing the API. You're expecting the API to be used that way. The cloud provider is expecting to be used that way. Therefore, as a vendor, you can expect that that's what's going to be there when you implement your solution. So there's kind of a nice contract that forms around that framework. So I imagine once that kind of becomes the de facto, that improvements in installation time, in evaluating services. So when it comes to like evaluating AV, it's very expensive to install antivirus across the whole fleet. And sometimes when you're doing a bake-off, you'd like to have all 4 of them installed across your fleet, right? But that's time-consuming and expensive. What if it's just an API click away or API license key away to say, hey, install this, install this, install this detection set. They all work in parallel, they all work off the same data, and they all feed into the same detection pipeline. Now when you're evaluating solutions, the switching cost might be almost nothing. So it's something to be aware of as this goes on. And the other thing is that cloud providers are known for moving very quickly with their services. So while you might look at some of these and say, wow, that's a little early, that's a little green, that doesn't have what I need, check back very quickly. Don't write it off for a year. You know, check back at every reInvent or Google Next or Azure's events. Look at what they're doing because they release very quickly. And kind of a personal note to security solution vendors, coming from a cloud native background these past few years, the way I think has changed of traditional security versus cloud security. If your solutions aren't taking advantage of the cloud provider APIs, if you're coming in heavy on top and you're making the DevOps teams or the infrastructure teams do a lot of heavy lifting to get your solution into place, when APIs might be available to make that easier, you're going to want to make your solutions work with those APIs, because if you're not, you're probably going against some of those assumptions with your approach, and you're causing more friction than doing good. And finally, some additional learning and exploration links here. The Cloud Goat from Rhino Security Labs, that's a great one. Flaws, which is the AWS by Scott Piper. That's another kind of a mini CTF challenge. It helps you explore those pathways as you're looking through some of the escalation and moving around inside of accounts. And yesterday's talk from Will Bankston of Netflix, Detecting Credential Compromise, that was a really good one. If you didn't get a chance to see that, go back in your time machine. It was at 10:30 yesterday. And finally, to kind of step back, if you're maybe a CIO level, look at the cloud security trend reports from Redlock and Palo Alto Networks. I think that does a very good job of encapsulating some of the high-level things that I kind of work through here. So when you're thinking of what trends and misconfigurations and tendencies are there in my environment, that's a really good place to get some data from their customer bases. So you don't have to just trust me. And with that, I say thank you very much. It's been an honor to speak to you today. Thank you.